Okay, this is the fifth video in trigonometry. This one we're looking at using trigonometry to solve problems. Example 1. Alan stands at A directly under a crane. From A he walks 10 metres to B. At B he measures an angle of elevation of 73 degrees. Now let's look at our triangle. It's in red here. We can label H as opposite 73 degrees. 10 metres is adjacent to 73 degrees, and we really just consider this triangle. Don't worry about the complexity of the question other than that. So we write down our formulas, SOHCAHTOA, TOA, the trigonometric ratios. Compared to 73 degrees, we are interested in opposite and adjacent, and we see that tan is the ratio to use. So our statement is that tan 73 degrees is opposite, which is H, divided by the adjacent, which is 10. Now we multiply both sides by 10, so we see H is equal to 10 tan 73 degrees. We type this into the calculator. And this, to one decimal place, is 32.7 metres. Okay, example 2. Again, just concentrate on the triangle in the picture. This time we're trying to find the length of the ladder. Now let's give it a name, so we'll call the ladder X, just to give it a sign. So the hypotenuse is X, and 1.2 is adjacent, and we have an angle of 70 degrees. So we write down SOHCAHTOA, and we see that we're interested in adjacent hypotenuse, so we choose tan. The statement is that tan of 70 degrees is adjacent of hypotenuse, or 1.2 over x. So what we need to do here is multiply both sides by x and divide both sides by cos 70 degrees. It's as if the x and the cos 70 degrees switch places. So x is equal to 1.2 cos 70 degrees. Now we type this into the calculator. X is 3.5 metres. Example 3. Again, look, the text might be complicated, but the triangle in the picture is not that complicated. So we see that we have two sides of this right angle triangle. We'll call the other side x. So to find the distance between Q and R, we could use Pythagoras' theorem. So the statement is the hypotenuse squared, x squared, is equal to 54 squared plus 112 squared. We can type this in one go into the calculator. So type it into the calculator. It tells us that x squared is equal to 15,460. So x is the square root of this number. And in the calculator, we see this works out to be 124 kilometers. Okay, now we're looking at question 2. It's measure of the angle PRQ. So I'm going to just draw a little diagram where this is. I'm going to give it a single letter name. I'm going to call it R, just for simplicity. Now, if I use the numbers given us originally, I see the opposite would be 54 and adjacent to R is 112. So we write down the trigonometric ratio formulas, SOHCAHTOA. This time we're interested in the one with opposite and adjacent in it. And we will choose tan. So my statement is that tan of the angle R is equal to opposite 54 divided by adjacent 112. So therefore R is equal to tan inverse 54 divided by 112. We always use inverse when we're finding an angle. Type this into the calculator. Second function tan. You can use your fraction button, 54 over 12. You can see it's 26 degrees to the nearest whole number. Okay, example 4. Here again, the diagram looks complicated enough, but we see there's quite a simple triangle, and train yourself to see the triangle. We know that one side of it is 25, another side is 30. The angle is 30 degrees, and we're to find the distance across the river, and we'll call that x, the distance between T and P. So compared to the angle 30, x is opposite to 30 and to 25 is adjacent. So we'll write down our three formulas. So katoa. We want the one with opposite and adjacent in it, and we see it's tan. So the statement is that tan of 30 degrees is opposite, which is x, divided by adjacent, 25. So if we multiply both sides by 25, we see that x is equal to 25 tan 38 degrees. I'll just type this into the calculator. It says to the nearest meter, so the nearest whole number we want it, and we see it works out to be 20 meters. Okay, example 5. Again, look, the text might look difficult, but look, what's the question asking? We want to get the distance that we're out from, the canoe is out from the bank. We see, because alternate angles, that this angle here is 28 degrees as well. We see the Z shape, that's the alternate angle. And we see opposite to the 28 degrees is 25. And we'll call the distance that the canoe is out, we'll call that x. And x is what we want to find. So looking at the triangle in the picture now, we're interested in opposite and adjacent. So let's write down our rules. So katoa, which one has opposite and adjacent in it? And we see that it's tan. So my statement is that tan of 28 degrees is equal to the opposite, which is 25, divided by the adjacent, x. So we multiply both sides by x, divide both sides by tan 28 degrees. It's as if the x and tan 28 degrees switch places. So we have x equals 25 divided by tan 28 degrees. And we type this in, we see it's 47 meters. Okay, the next question. Again, this time we have three triangles in this picture. We're interested first in writing out PZ, so I'm going to call that X. So if I consider, actually just the large triangle, I'm going to just draw it to make it clear in this thing. I'm going to draw a little yellow line around it. The reason I'm choosing the large triangle is I have more information about this triangle. I know the angle of 44 and I know the side of 18 meters. And we're interested in the side X. So compared to 44, X is opposite, 18 is adjacent. So I'm interested in the opposite and adjacent, so I choose tan. Statement is that tan 44 degrees is opposite, which is x, divided by adjacent 18. Multiply both sides by 18, and this tells me that x is equal to 18 tan 44 degrees. And type this into the calculator. And the answer is 17.4 meters to one decimal place. Okay, the second question, work out the angle of elevation from the point P. Well, a 2P from the point Y. Now let's see where the point Y is. So at the point Y, look, this is the angle it must be talking about. I'm going to call that angle Y to give it a single letter name. There's no really other angle at Y that points up to P. So this is, even though the language might seem complicated, it's obvious if you look at the picture. So this is the angle of elevation, the angle looking up at P from Y. So I'm interested in the opposite and the adjacent of 7. So I choose tan. The statement is tan Y is 17.4 over 7. So Y is tan inverse 17.4 over 7. We always use the inverse when we're finding an angle. So type this into the calculator. And it says to the nearest degree, it's 68 degrees. Okay, let's consider the third question, the size of the angle XPY. So let's just mark off what we're talking about here, the angle XPY. Now I might fill in the 68 degrees first. So the angle I'm considering is this angle up here. This is the angle XPY. Now the situation here is we have this exterior angle is 68 degrees, and the exterior angle, this is not using trigonometry but geometry, is equal to the sum of the two interior opposite angles. So in other words, the angle at P plus 44 must be equal to 68 degrees. So if we take 44 from 68, we see that P is equal to 24 degrees. So that was just simple geometry. Okay, thank you for looking at these videos. I hope it was useful.